Hello, Cardstack community. This is Chrissy, the founding director of the Cardstack Project, giving you an update on Gitchain. I gave a talk about a couple of weeks ago about the overall strategy of Gitchain, which is something we've been working on, and we have built application on top of it. And some of the application we built was not open source. So we have this application called Cardboard, which is a decentralized medium type of application. So we want to use this opportunity to show you how Gitchain, which is something that's already working and running on a permission ledger, would work with a content style application. So Alex Bella recorded a little demo a couple of days ago, and this week we're in the middle of reconfiguring the studio space here, so we will be able to do a video again next week, but right now it's audio only. So previously, if you want to watch me talk in the studio space, there is a introducing Gitchain technical talk that goes through most of what I'm going to demo today, but in a more detail. If you haven't watched that video, the really only thing you need to know is that there is a idea of Gitchain, which takes a Git repository, which is code, content, and data in a file format, and then it turns into a pack file that gets stored in distributed storage, in this case S3, and then that is synchronized. That pack file, the pointer is synchronized on Hyperledger Sawtooth, and then that allows the information to be on chain, but there's an off-chain reference with the distributed storage that get recreate or reify the entire of the repository in your Git repository. Cardstack is a application framework that is designed to work with Git because we want to build a framework that allows us to integrate with blockchain, and Git is kind of like a blockchain. And you can learn more about that in my other video. And those items within the Git repository becomes cards in the data model in the user hub, which is like an application server, and that essentially run the UI. So we're going to show you how that works. So what's different and what's specific about this particular demo is that we have two instances of Cardstack Hub running. So two different, you can consider them different servers. They happen to be running on the same computer and laptop, but they're actually different instances. One of them is publishing into Gitchain, almost like publishing GitHub, and then that gets synchronized on the blockchain. And the other one do a chain sync, and then it downloads the pack file based on the pointer from the chain, and then recreate the Git repository and then reanimate the thing. So that entire thing is on Gitchain on the Cardstack repo. Without further ado, I'm going to ask Alex Bella, who's been working on this Gitchain and other integration in the hub around this, to show you what he has come up with.
So what we're looking at here is an instance of the Cardboard app, and what I'm going to show is syncing the backing data, which is stored in a Git repo, to another instance of the Cardboard app. But I'm not going to use GitHub or even the Git protocol to do that. I'm going to use the Hyperledger blockchain and off-chain storage. So right now we've got this running on localhost port 4200, and if I open a new tab and hit port 4201, I've got a new instance of Cardboard running, but there's no data there currently. So that's why it's throwing an error. I'm going to clone the backing repo and use that for the second instance. So what I'm going to do is I'm going to run the command to clone the backing repo from the first instance of the Cardboard app into a new location on my hard drive, and then I'm going to point the second instance of the app. So I'm going to run the Git Chain clone command, and that's going to go and look at the blockchain and see what the current state of the repo should be for this tag, and then it's going to set up a Git repo and go to the off-chain storage and download all of the pack files and reassemble them. So now if we look in this repo, it's just a bare Git repo, but it's going to contain the files for the initial Cardstack app instance. So now what I'm going to do is I'm going to switch and I'm going to start up the second instance of the app. I've just got a script to start that up, and that's going to be pointing at the cloned repo. So when I refresh the second instance of the app now, it's cloned all of the data across. So we can go and look at one of the articles, and these are now linked together So now if I go in the first instance and I change the title, for example, of one of these articles and save that, that is persisted to the database sorry, if I refresh the page it shows up, but if I reload the page on the other instance it's not quite there yet because the blockchain is in the process of syncing. But if I wait shortly afterwards, there we go, the data is updated and synced between the two repos. So this is a two-way sync. Any changes that are made to this instance will be synced back to the initial instance as well. And we're going to be building additional functionality on top of that to have, instead of just automatic sync without any intervention, there's going to be workflows and processes and that kind of thing that we're going to build in. But this is the base functionality of pushing via the blockchain.
So that was a little quick overview from Alex on how that this thing all works. What we are doing now is we're porting Git Chain, the bottom part, the part that uses that goes to the layer 1 protocol, to Ethereum as the kind of sync ledger, the mainnet, and to IPFS for storing the actual pack file itself. Now, IPFS is designed with a Git-like semantics in mind, but I think most people are not using IPFS as a file system. It's not really fast enough for it, but it's more as a place to put larger thing, and then you reconstruct the file system kind of on your own local computer. So we're still using the Git protocol as the local protocol. So reading, writing file, you don't want to be waiting on the network. You don't want to be mounting that and be slow. But we are using IPFS to kind of opaquely store the pack file, which is like a zip file of the recent changes, and then be able to get it down. So that's a fully decentralized, very Web3 version of that. The good thing is that everything on top of that is exactly the same. The only thing we're changing is the adapter, which is a plugin system in the Cardstack Hub to make that happen. We'll demo that when we're ready, which should be soon. The second thing is that we think of Git Chain as not just a way to store content, because Git in storing content is a relatively new thing. Any type of cards, any type of things that has an application state, it could be an invoice, it could be a legal document, it could be even something data-oriented, some of data file, data set, can be visualized as a card in front of it and then stored as one or more interlinked file in Git and can be checked into GitHub. So anything that can be checked into GitHub can be put in a Git chain. So we believe the Git chain is a very, very general purpose layer 2 protocol, not for things that's like machine, like playing chess or something like that. A lot of the blockchain inspired layer 2 architecture try to recreate the blockchain somehow in layer 2. Git is not exactly a blockchain because you can fork and merge, but it's still a layer 2, and then we're really excited about architecture. And I think that the Git chain with Cardstack will allow you to pretty much build any type of application from social media to data management to CRM in the business space, as long as you can serialize your data in some sort of APIs, which people build API knows that you can pretty much serialize everything to JSON. So it just makes sense that storing that in a linear hash linked kind of way can allow you to basically share and persist and synchronize any type of application data. So layer 2 for the win. And finally, one of the thing that when you have this nice user experience is that you don't really want every single time you save a file or you commit something to have to pull up a kind of like, a Trezor wallet or Ledger or something like that to sign it. So we're working on a non-custodial wallet and key signing protocol that is part of Cardkey. So you can kind of using a very safe way, leveraging some of the latest multi-party computation algorithm that's been kind of gaining us adoption, using that as a way to have the server or a set of servers working together on your behalf to sign these lower stakes transactions. Now, you may not want to use this right now to sign financial transaction with large amount, but as a way to do this in the background without user intervention is pretty important. So Cardkey is a big part of our usability story about using crypto-based protocol, including sending things to Ethereum, putting things to IPFS, and possibly doing some symmetric encryption between. Without that user intervention and without that needing to click on MetaMask is a really big thing. So we're going to do an announcement on Cardkey a couple little bit. And there's a bunch of stuff that we're going to use Cardkey for, which is just signing a transaction. And you can certainly imagine some lower value transaction that can be done the same way as well. So that's a companion piece to make sure that using Git Chain is as easy as using a website, using GitHub or something like that. So announcement coming couple of weeks has been something we've been working about for about the last few months on as a way to complete the user experience story on something like Git Chain being the underlying technique. So that's it for today. And when we back next week and get everything, the camera equipment set up after the reconfiguration is done, I'll come back and talk to you about some other process and project we're working on around Cardflow, and certainly soon thereafter around our new protocol design that unifies a lot of things we've been talking about, including Git Chain into one unified product suite. We'll talk soon.